The LI for this lesson is to be able to use the constant acceleration formula to solve problems involving vertical motion under gravity. And what we're going to use is we're going to carry on using the suvat formula that we've used for the past 2 lessons. The only difference is that we've got gravity involved, and gravity is what affects the acceleration. So gravity causes all objects to accelerate towards the Earth. And now, if we ignore effects of air resistance, which we're going to do for all of these questions, then the acceleration downwards towards the Earth is constant. So if I drop a pen, if I drop a brick, the amount it accelerates towards the Earth is always going to be constant, and it doesn't depend on the mass. And the acceleration due to gravity is 9.8 meters per second squared, and that is 9.8 meters per second squared downwards. Now the actual acceleration is 9.80665 meters per second squared downwards, but we're just going to use 9.8 for every question, unless you are specifically told otherwise, but most of the time we'll use 9.8. So here we've got a book falling from the top of a bookcase, and the bookcase is 1.4 meters above a wooden floor. So we've got this book here on the shelf, and the distance towards the floor is 1.4 meters. It says find the time that the book takes to reach the floor and the speed at which the book strikes the floor. So let's fill out what we know. Again, writing suvat. With gravity problems, the only important thing to focus on, or one of the important things to focus on, is the direction. So I'm going to take the downwards direction as being positive, and it's always good to write down which direction you are taking as being positive. So here I'm going to say a move downwards is a positive move. So S, the displacement. So from the top of the shelf to the bottom of the floor, that displacement is 1.4 meters. The initial velocity. Now, I do know the initial velocity because of the way the question is worded. The book is just falling off the bookcase. It's not been pushed, it's not been thrown downwards, it's just falling. And therefore the speed at the top, the initial speed, the initial velocity is 0 meters per second. I don't know the final velocity, that's what I'm going to work out in part B. I do know the acceleration. We've said that gravity pulls you downwards at an acceleration of 9.8 meters per second squared. And I'm taking downwards as positive, so it's a positive acceleration downwards. And I don't know the time, I want to work out the time. So then I need to think about which formula I'm going to use. So I'm trying to work out the time, but I have S, U and A. So I am going to use this formula here, formula 4. It says S equals UT plus a half AT squared. S is 1.4, U is 0, so I can say plus a half 9.8 T squared. Now I can rearrange that on my calculator to work out my value for T. And I've not done this one before, so I'm going to have to find my calculator now to work out my value for T. There we go. So firstly, I'm going to do 1.4 and divide by 9.8 over 2. So I know that T squared is equal to 2 over 7. So T must be equal to 0.534. So it takes 0.53 seconds. That's the time that it takes for the book to fall to the floor. Part B then is asking for the speed at which the book strikes the floor. So this one is asking for the value of V, the speed at the bottom, the final speed. So again, I can have a look up here at what I'm going to use. Well, the nice easy one to use, I could use this top one. I have T because I've just worked it out in part A. But I could use quite a lot of those. The only thing, I could use any of those I want to. But I'm going to use the top one. Why not? If you think you might have made a mistake in the first question in part A, it might be a good idea to use the equation that doesn't involve T. That might give you a better answer. But we could do both. We could check that it gives us the same answer either way. V is equal to U plus AT. U is 0. A is 9.8. And T is our answer we've just got, 0.53. Type all that in and get my answer for V. Oh, sorry, can't quite see that on there, can you? So I've got my answer for T there, and just need to times that by 9.8 to get my velocity of 5.24. Oh, 24, not 34. meters per second. And that velocity is going to be downwards towards the floor, because downwards is what we're talking about as a positive. Okay, let's have a look then at the next example. This time we've got a ball projected vertically upwards from a point X, which is 7 meters above the ground. So if we imagine the ground is here, the ball is already 7 meters above the ground, and it's being projected upwards. So you could think thrown upwards, or somehow it is projected upwards, with a speed of 21 meters per second. Find firstly the greatest height above the ground that is reached by the ball. So we're going to think about the greatest height. So the ball is going to go upwards, it's going to keep on going upwards, and then it's going to start coming downwards. You know, you've probably thrown a ball before, you know that's what happens. So I'm going to find the point at which the ball is at its highest, up here. Now at that point, the ball will be travelling upwards and upwards and upwards and upwards, and then it starts travelling downwards, 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 downwards. So at that point at the top, I know that the velocity is equal to 0. Because the velocity was going upwards, it's slowing down, and then it starts coming downwards instead. So at that changeover point, the velocity is 0 when it's changing between going upwards and going downwards. So again, I'm going to fill out what I know. Now this time I've decided I'm going to take upwards as positive. So upwards is my positive direction, and this is where we can really see how important the signs are. S is what I'm looking for. I'm looking for this displacement here. U, I know, is 21 meters per second. Oh, don't know what I've written there. Meters per second. Because I'm going upwards as positive, and it was projected upwards. V is 0. We said at the top, the velocity is 0. Acceleration. Well, I know I'm talking about acceleration due to gravity, so 9.8. However, gravity acts downwards, and I'm taking upwards as my positive. So therefore, my acceleration is negative 9.8 meters per second squared. So I'm trying to find out what S is going to be equal to. So if I have a look again, oh, I've lost my little sheet. There we go. Have a look at which formula I'm going to use. I'm going to use, not that one that's got a T in it, I'm going to use formula number 3 here. So V squared equals U squared plus 2AS. If I rearrange for S, I get that V squared minus U squared divided by 2A. That's what S is equal to. So let's put that in. So V is 0, so 0 squared minus 21 squared, all divided by 2 lots of minus 9.8, because remember, A is minus 9.8. And you put that into your calculator to see what we get. So I've got 0 minus 21 squared, all over 2 lots of negative 9.8. And I get an answer of 22.5 meters. Now I'm not actually finished, that is not my final answer, because it says the greatest height above the ground. Now I've just worked out, let's get rid of that this height here is 22.5. But to find the height above the ground, I need to add it on to the 7 meters. So the greatest height above the ground is going to be 22.5 plus that 7. So that gives me 29.5 meters. That's my greatest height above the ground. For part B, it's the time of flight of the ball. Now, there's a couple of different ways we could work this one out. Let's have a look what we know. SUVAT. I am going to think about from the start all the way to the end when it hits the ground. Now, the displacement from that beginning position to the end position, I know it's moved 7 meters, and I'm going to say negative 7 meters because it's gone downwards, and I'm going to again use upwards as positive. So my displacement is negative 7 meters. U, the initial velocity, is 21 meters per second upwards. So I'm taking upwards as positive, so I'm going to write 21 meters per second. And acceleration is negative 9.8 meters per second squared. And I want to work out the time. That is what I'm looking for. So I'm going to use S equals UT plus a half AT squared. And I'm going to type all these in. I've got negative 7 equals 21t plus a half, which is, because a is negative, minus 9.8 over 2t squared. And I could rearrange that so that I get 9.8 over 2t squared minus 21t minus 7 is equal to 0, and solve to find out my values of t. So I'm going to use the equation formula. Where's my equation one gone? Here we go. And I've got a polynomial of degree 2. So first I've got 9.8 over 2 minus 21 minus 7. And I get that t could be equal to 4.597, so we could round that to 4.60 seconds. The other option for t is negative 0.31. Now clearly it can't be, we can't have negative time, so that's not going to be one of our answers. So my final answer is that the time is equal to 4.6. I want to also show, I know this is getting a bit messy now, I'm sorry about that, but I also want to show how I could have done it a different way. Now I could have taken the downwards as positive. If I was taking the downwards direction as positive, the displacement from start to end would be 7 meters and not negative 7, because it's positive 7 if I'm taking downwards as positive. The initial velocity would be negative 21 because the initial velocity is upwards. So if I'm taking downwards as positive, it would be negative 21 meters per second. Final velocity we didn't know. The acceleration would be 9.8 meters per second squared because I'm taking downwards as positive. Gravity acts downwards, so my acceleration downwards is positive. And the time is what we're trying to work out. Now, if you use these variables and put them into the suvat formula, you would get the same answer as we did here. Okay, so it doesn't matter which direction you take as positive, whether it's upwards or downwards, but what does matter is that you are consistent with each of your approach. You couldn't suddenly start having that the displacement's negative, but that the acceleration still is positive. Yeah, as long as you choose and you stick to your choice, then you will get the correct answer. Okay, I'm going to go on to the second video to do the next 2 examples because there's not quite enough space to upload such a long video on YouTube.